Hello, everybody. So, my apologies for some delay on this matter, but I wanted to check everything thoroughly and make it so that it takes minimal effort from you to actually try and debug your practical exercise number 3, training of neural networks, if you have any problems. So, the idea is that I have run this program for my own video recorded program, which was here. Yes, so basically the same which I explained, which actually works properly. And in the process, I saved all the results. That is the predictions, the gradients, and the cost functions for specific values of lambda 0 and lambda 5. And further idea is that we are expected, of course, if you run my neural network, which is provided in this data file x4 weights mat, which is available in the Ortus here. Yes, pre-trained neural network, and the same data set. So your functions are supposed to have exactly same values. That is where we can actually compare it and understand what exactly works wrong. So here I have added this data file, yes, with the very accurate values from my program. This is the function in Python which goal is to test your function values and compare them with my reference values and mark any possible problems within one of your functions, which are backpropagation, feed forward, and cost function. Yes, and this particular is the script code which you are supposed to run, and it actually does exactly that. So you specify what is the name of your feed forward function, what is the name of your backpropagation function, compute cost function, yes, and then accordingly it inside of that function loads this data file and compares all the values. So I will not delve into details in this automated test function. It's quite big and maybe a little bit complicated. Yes, it uses specific tolerance acceptable values which you can change, but that's not necessary. Yes, so instead we are going to try and run it. So there were two groups, yes, and accordingly, one of the groups was having one type of issue, another group of another type issue. So let's now try and apply this script to try and solve problems and see if we can make this neural network running. So we'll start with the group one, which was having the issue of not even starting the training procedure because of some matrix dimensions mismatch. So it says cannot reshape array of size 127 into shape 127, 26, and 1. Yes, so after this point, nothing really happened. So what we are now trying to do is to actually upload those files which I have provided, which are two files, autotest Python, script function, which contains a function we are going to use, and reference outputs in the NPZ format, that is data format from NumPy package, yes, and accordingly we are going to load that data. So these are correct answers, and the autotest calculates values with your functions and compares them with these correct values. So let's see how this is going to look like. All that you need to do is to actually create a new cell. That is, of course, first you have to run the program. Yes, I have already done that. Yes, so we are now stuck at this position. So at the end of the code, you simply copy that script provided in the Ortus system here entirely. Yes. So what it does, it loads again the data set, splits it. Now that's very important that we shouldn't forget to do one-hot encoding because originally it's a label from 0 to 9. And a little spoiler, that is the issue why this matrix misshape happens here, which I will show you shortly. Then we load the pre-trained neural network. My neural network used in this example has 25 hidden neurons, so you have to use the same number. So basically you can just copy-paste the script, and all that you need to change, if you have specific different names for this feed-forward function, which is here. Yes, so that is the name of this function. the backpropagation function, which is called, in my case, backprop, and in this example we have been running in computer class, it also called backprop, so the name has to be exactly the same as in your actual program. And finally, compute cost, which is also here. So if I run this test now, it's going to say several things. Specifically for feed-forward check, it actually shows that every parameter has been calculated with this function properly. The cost function, both for lambda 0 and lambda 5, is calculated also properly, but the gradients, that is backpropagation, actually failed. But this is not the reason why this program doesn't work. Here, it should have started training, but eventually not really reaching it. So what is the problem is, as I said, this one-hot encoding. Let's assume now that I have forgotten to do this one-hot encoding, so I didn't do it. And if I try to run this test, it's going to complain, cannot reshape array of size 27 into shape 26 and 1, which is exactly same problem as is actually happening here. Yes, so that means that this Y train hasn't been converted to categorical. And if you look here, that is indeed the case. So we split the dataset into training and testing parts and actually didn't do to categorical. Yes, so I already have this fixed and tested. So let me just copy these two lines of code that is actually doing to do this conversion into categorical. Yes, and if we try to run this script now, yes, it shows some other issue. Yes, so accordingly, if we check back to our script and fix that problem here, again, you see that it mentions exactly the same issue here in the backpropagation. So now we know that the backpropagation function actually has some issues. Let's go to the backpropagation function and check what is wrong there. Well, I already compared it very exactly, but what you have to do in this situation is to rewatch the video record and thoroughly fix any possible mistakes, of which I have found two problems with this backpropagation implementation here. One specifically here, as you can see, it calculates theta 1 gradient and theta 1 gradient. It is supposed to be theta 2 gradient here. Yes, so that should fix this problem, and you update the function. Accordingly, if you try to run it, here it still fails, but not with the some problem crashing the function, but actually incorrectly calculating the value. So if I were to try to train a neural network, it will start. Well, actually, so I suppose X train, Y train. Wait a minute. So I will simply try and run everything from the beginning. Yes, so some issues are there. So as you can see now, it starts training. It is going to take like 15 minutes or so, so we are not going to wait. And in the end of the day, it's going to fail and find incorrect results because there is another issue with the gradient here. So we can already see that because this auto test actually said that it's incorrect. So gradients check is fail with regularization and without regularization. So that means it's not even worth it to wait those 15 minutes to see that it didn't train a neural network. It will try to train it, but it will fail to train any meaningful results. So the accuracy will be bad and so forth. But the program will work. It's just the problem with how exactly gradient is being calculated. So we need to fix that. Again, you need to go thoroughly with that. But at this point, we can say, for example, that it doesn't matter if it calculates properly or not. So let's maybe check the formulas once again, specifically here, yes, for the backpropagation algorithm, how we calculate it. All the way up to this delta, theta 1 gradient, theta 2 gradient, all the way up to here, that is happening in accordance with this formula here. And the problem specifically in this case was in adding this regularization. As you can see here, this gradient here is supposed to be the theta 1 gradient divided by m plus regularization of theta 1. In our case, however, we say that the theta gradient is just theta 1 multiplied by regularized lambda, which means effectively we forget about this part and simply say this part here is equal to lambda m theta 1. Yes, which is exactly what's saying here. That is because we are supposed to actually add on top that. So that is basically like theta gradient plus regularized part, yes? Or for short, we can also use this kind of notation like we did here. Now, if we update this function, now it's actually going to pass all the tests. Everything is fine, yes? And if we were to run this script completely, it is going to train a neural network. It will say optimization terminated successfully. Here is the cost function value, and if we try to display the accuracy score, then for training data it's going to be 1.0, for testing data set it's going to be 0.95, which means the neural network is actually trained and works properly, so the problem has been fixed. Yes, that was the issue. Well, while we are at it, let me intentionally introduce some mistake to give you some more examples of what can also go wrong and how. For example, let's say I'm going to the feed forward and say I have forgotten to calculate sigmoid of z, and I just said A3 is just Z3. So now we'll see that actually in this case everything will fail. The feed forward check fails, particularly at the step A3. Yeah, so you will be able to actually trace which one exactly of those is wrong. And of course, if for example A1 will be wrong, then everything else will also fail. Yeah, so we intentionally made mistake on the last step, so only last step failed. Now the cost function actually uses feed forward or predict, so obviously it will also fail, and the gradient will also fail. Now let's, for the sake of complexity, also have a second mistake in the gradient here. Say I have forgotten to divide with m this lambda. Yes? So basically I am missing this divided by m for lambda 2, for theta 2. Now obviously, unless you fix the issue with the feed forward, you will not be able to even notice that there is some mistake here. So see, it still fails everything. But let's go and see. Okay, so now I know that A3 is calculated incorrectly. I go to feed forward function. Yes. I notice, okay, it's supposed to calculate sigmoid here. So I add sigmoid here. Don't forget to update this function actually. Yes, so I run this cell to update the function. And then I try to run this test again. So now it says that feed forward works correctly. Cost function works correctly, gradients without regularization works correctly, with regularization actually failed. So that means the problem is related to lambda and that part, which is exactly the place what I have been tampering with. So, okay, now as you can see, everything works here exactly. Let's go through the second group's practical exercise task, the same one, and notice their mistakes. So in their case, the program was actually running, but it failed to produce meaningful results, meaning there were no serious problems with the compute cost, backpropagation, or feed forward. Yes, and what instead happened is it just was unable to actually train a neural network because cost function was quite huge. Yes, as you can see here, it's 5.8 compared to whatever was here 0.00 something. Yes, this one here. So that means that on paper everything is working, but actually solution cannot be found. Yes, why that actually happens is probably because of some problems. So let's also do the same thing here as well. So I'm going to add a new cell, paste that script, which is available in the Ortus. I have already uploaded all the necessary files as well. Yes. And let's try to run the test. So as you can see, it failed the gradients calculation, yes, and it's both for regularized and unregularized, meaning that we have to go to backpropagation and find the problem. Now again, you have to check everything thoroughly and compare with the video record, but I have already found the issue here. Yes, so let's see here how exactly it is being calculated. So we calculate this delta 3 error, delta 2 error, then accumulate everything, and after the for loop has finished, we divide with m and then add regularization part. So here, this is where actually it's going wrong. You can see all of this stuff happens inside of the for loop, including the return, which is wrong. Yes, for example, if we were to compare the example of the group 1 for the same one, you can see that for loop actually stops at this update accumulation, and then outside of the for loop we divide with m and add regularization, pack them, and return values. So this is a syntaxical mistype. Yes, so I have to accordingly ident this by one position, everything here. Yes, so that is being processed outside of for loop. Which, by the way, here particularly I did add comment in group 1, and therefore we didn't make that mistake here. Here it was basically being unaware of this problem, yes, and of course, once we update this function now and try to run this test, you see that everything passed. So again, I have already run the training, which takes roughly like 7-8 minutes, yes, and as you can see, the accuracy results are comparable and basically similar. So hopefully this will help you to actually pinpoint the problem because, well, if you have specific problem in one of these functions, it is going to mention it here. Now, if everything here is okay and the neural network still cannot be trained, that means only one thing can go wrong. That would be this minimize itself. So you should very carefully then check if you have randomly selected initial theta values, if you have performed the how it's called one-hot encoding. Yes, so in particular for group 2 we did that right away here. One-hot encoding, it's here, yes. And finally, obviously, of course, if you have specified everything properly inside of the minimize function. Now, you may ask, maybe this is some problem with data processing, but no, at this point, if everything here passes, okay, that means your data itself is also correct. Yes. Now, the only thing that can go wrong, as I said, would be conversion to categorical. Yes. And at that point, well, that's probably not even going to work. Yes. Okay. So that basically concludes this part. Yes. Feel free to ask any questions if you still cannot solve your problem. But at this, with this script, actually you should be able to at least narrow down the area of search and hopefully do this practical exercise. Thank you for attention.